So we've been working on the unit circle. We filled in the entire blank unit circle in the last class. And now we'll do a little bit of terminology today, okay? So first, when we're measuring angles in this circle, and I'm talking about something over here, the angle starts here on the x-axis and rotates counterclockwise when we measure it, okay? So this first side right here on the x-axis, that is called the initial side. Okay, so the initial side, I'm just going to use an arrow and point. The initial side is the x-axis. That's where it starts. From the origin going off and to the right. The terminal side is where it ends, where it terminates. So if the angle starts here and on its initial side, when we rotate it this way, that is the terminal side. Okay, so the terminal side is where it terminates or ends. All right, which brings us to the reference angle. Now, the reference angle, we call a reference angle because we refer back to that, and I'll explain that as we move along. We refer back to the reference angle to try and find coordinates. The reference angle is always between 0 and 90 degrees. And it is and I hesitantly use this term, but I'm going to say for learning purposes, it is the distance to the x-axis. Okay, although it's an angle, angles are measured in degrees, it's not a distance essentially, but so reference angle for this would be this angle right here. That is the reference angle. It's how far away is it from the x-axis. And a reference angle is always between 0 and 90 degrees. Okay? So if we wanted to find the reference angle for 150 degrees, okay? So I'm going to draw a circle, and you guys don't need to do this. Okay, but if I were to draw an XY axis, 115 degrees, remember my quadrants? This is the first quadrant, this is the second. This is quadrant 3, this is quadrant 4. And so if I started with my initial side and worked this way, 115 degrees would be in the second quadrant. This would be more than 90, but less than 180. So how far away is that from the x-axis? Well, if that's 115 degrees, I know it's 180 to get to the x-axis. 180 minus 115, that would give me a reference angle of 65 degrees. Okay, again, always between 0 and 90. If our angle went negative 100 degrees, so let me erase this and kind of animate what I'm talking about here. So angles typically go this way. Whoops. Typically go this way, but if I want to go negative 100 degrees, I'm going to go this way, clockwise. And I would go past negative 90 to negative 100 degrees. I'd be down there in the third quadrant. How far away am I from the x-axis? I would be 80 degrees away. Okay, 80 degrees away from the x-axis. That is my reference angle, is 80 degrees. All right, any questions on those two? All right, well, the next ones, we have 540 degrees. Well, that's a little odd because, you know, a circle is 360, right? And so 540 degrees, well, if I started with, you know, here's 90 degrees, there's 180, there's 270, there's 360. 360 plus another 90 would be 450. So where is 540 going to end up? Which quadrants? Well, let's see. We know it's more than one revolution, right? So we could do 540 minus 360. So let's do a little old school subtraction here, right? So 14 minus 6. So it would be 180 degrees, meaning 540 degrees, I would go around 360 plus another 180, leaving me right here. Well, how far away is it from the x-axis? 0 degrees. So we would have a 0 degree reference angle. So again, the reference angle is how many degrees it is away from the x-axis. And so your answer is always between 0 and 90, inclusive of 0 and 90. All right, next, coterminal. Think about that term. Co means together, and terminal means to end. So angles that end in the same spot. Okay, how do you find a coterminal angle of 15 degrees? Well, if you had an angle of 15 degrees, say right here, okay, that would be in the first quadrant, of course. Well, I could go all the way around the circle 360 degrees plus another 15, giving me a grand total of 375 degrees. So 375 degrees and 15 degrees, they terminate in the same spot. They are coterminal. Go around the circle twice and then add the 15 degrees. And go around the circle 10 times. Okay, I could find an infinite amount of coterminal angles. I also can go the other way. So if I did a negative angle, I wouldn't have to do a full circle. So it's 15 degrees short of negative 360. So 360 minus 15 would be 345. So if I went negative 345 degrees, that would be another coterminal angle. All right, so for, let's say, part B, for negative 135 degrees, first I would figure out, all right, what quadrant is that in? Well, negative 135 degrees, I'm going clockwise because it's negative, and 135 is less than half a circle. It's more than 90, but less than half a circle. So I'm going to end up here, down in the third quadrant. So to find a coterminal, I could go this way. Yes.
How do you get there if it's less than 180?
So remember, it's negative though, correct? Okay, so yeah, we started here and we're going this way instead of going this way. Okay, because it's a negative angle. And so if this is negative 135, I could have a positive coterminal. So I know that, let's see, I'm going to be in the third quadrant. So if I went more than 180, less than 270, so if I went 225 degrees, that would be a positive coterminal.
And realize like these two numbers, if I took the positive 135, those add up to 360. They make a full circle. Therefore, they would be coterminal. Okay, I could go past 225 and add another 360 to that. That would be another coterminal. So if I did 225 plus 360, that's going to be 585 degrees. That would be another coterminal. Okay, so we're looking for any angle that ends, terminates in the same spot. All right, any questions on kind of that vocabulary stuff and what those terms mean? Got our reference angles, we've got our coterminal angles. Okay. These six trig functions we've already talked about, those reciprocal functions. So we're going to apply that. It says find the six trig functions for, part 3A here. First, I'm working in the second quadrant. And I have a coordinate at -3, 4. So what I want to do is drop a perpendicular to the x-axis. And I know two of the lengths of the sides of this triangle. I know that the bottom would be -3 and the left side would be 4. Because if my coordinates are at -3, 4, I go to the left 3 and up 4. So now I want to find the hypotenuse. So I could do a little a squared plus b squared equals c squared. Or maybe I'm lucky enough to remember that is a 3, 4, 5 triangle. Okay, if we did this arithmetic here, we would get c equal to 5. So I want to find the six trig functions for this. So I want to find the sine, cosine, tangent, cotangent, secant, and cosecant. So let me write those down. The sine of theta, the cosine of theta, tangent, theta, cotangent, secant theta, and the cosecant of theta. But because we know the three sides of the triangles, we're just going back to our old SOHCAHTOA days and just writing down those proportions. So the sine of theta, okay, so we're talking about this angle in here. It's going to be the opposite, which is 4, over the hypotenuse, which is 5. So the sine of theta is 4/5. The cosine of theta would be the adjacent over hypotenuse. Now, notice the adjacent is a negative. So it is -3/5. And the tangent is the opposite over the adjacent, which is 4/-3 or -4/3. Now, if we have those, they're reciprocal, it should be pretty easy. We just flip them over. So the cotangent is the tangent flipped over, so that will be -3/4, because those two guys go together. The cosine goes with the secant, so I'm going to flip that over and make that -5/3. And the sine goes with the cosecant, which would be 5/4. So in part B, real similar problem. We're in the fourth quadrant. I won't go through and find all 6 trig functions, but let's do some of this because I think the numbers aren't going to be as nice. We want to draw a perpendicular to the x-axis. I know that the top of that triangle will be 6 and the right side will be -3. Okay, because of my coordinates. Now, if I wanted to find my hypotenuse, I'm going to do Pythagorean theorem, 6 squared plus -3 squared is equal to c squared to solve for c. And so I'll give you a second to catch up writing. That c comes out to be the square root of 45, which of course we've simplified radicals, right? It's going to be 3√5. I will place that as my hypotenuse. And the hypotenuse, of course, is a distance, so it's always positive. Okay, so now, for example, if I want to find the sine of theta, okay, so I'm finding the sine, this angle in here is the opposite, which is -3, over the hypotenuse, which is 3√5. I'm going to have to do a little arithmetic to simplify and rationalize that. And so the sine would be -√5 over 5. So the reason I want to show you that is that the answers are not always as clean as we had in part A, where they were nice, nice fractions without any radicals. Yes.
How is the angle inside of the triangle? Not the one like right
Yeah, I see what you're saying. So you're saying like theta is listed here, right? And so we use this as our theta. So we're always using, that's a great question, Olivia. We're always using its reference angle. Okay, and its reference angle, remember, is the distance, so to speak, to the x-axis. And so this is the reference angle for theta. So the sine of that reference angle is always the same as the sine of theta. Okay, good question. Anything else? All right, so last thing here for understanding the unit circle, let's just talk positives and negatives in terms of the quadrants. Okay, so we have, I'm gonna move this out of the way here a little bit, guys. So we have our 4 quadrants. Let's go counterclockwise. Remember, in the unit circle, the sine is the y value, the cosine is the x value. So in the first quadrant, the y value is positive and the x value is positive. And the tangent is the sine over the cosine. When you take a positive divided by a positive, you get a positive number. So all of those sine, cosine, and tangent, all those functions are positive in the first quadrant. That's not true in the second quadrant.
Because in the second quadrant, the sine is positive, because that's a y value. But the cosine, which is the x value, is negative. And therefore, the tangent will be negative, because tangent is sine over cosine. You take a positive divided by a negative. Think of our last, sorry, my screen's lagging a little bit. Think of our last problem here. Okay, we were in the second quadrant. The sine was positive, but the cosine was negative. Okay, that's going to happen. That will always happen in the second quadrant. In the third quadrant, the lower left, well, the sine, which is a y value, that's negative, and the cosine is negative. Therefore, the tangent is positive because a negative divided by negative is positive. And then last but not least, in the fourth quadrant, the sine, which is the y value, is negative. The cosine, which is the x value, is positive. And therefore, the tangent is negative. Okay, so a little device some students helped use to help them remember, like in the first quadrant, all of them are positive. In the second quadrant, just the sine is positive. In the third quadrant, just the tangent is positive. And in the fourth quadrant, just the cosine is positive. And so a little mnemonic device is that all students take calculus. All students take calculus. Okay, if you want to help remember which ones are positive in which quadrant. Any questions?